Dear students, in this module we will discuss about the mean age at marriage. This module will be contributing in enhancing our knowledge about mean age at marriage and estimation of mean age at marriage. Why do we need to study the age at marriage? To study the demographic trends, the age at marriage is a better measure than some of the marriage rates mentioned in previous modules, especially in a society where universal marriage is the norm. And in such a situation, the average age at marriage indicates the marriage pattern, but it also indicates the possible trends in fertility. And as all of us know, delayed marriage tend to delay the pregnancies also. When data on age at marriage are available, the average age at marriage can easily be computed. As we discussed in other modules, the data limitations are to be kept in mind while estimating the demographic parameters. This is one of the most widely used measures of marriage that is used to compare the marriage pattern of different populations. Usually, average age at marriage refers to the first marriage, and if remarriages are taking place, that fact has to be either specified or average should be calculated separately for each of the marriages in order. In any cohort, there will always be a few who will not get married at all, and in view of this, average age may not be completely meaningful. In such situations, median age at marriage can be calculated. Similarly, model age at marriage can also be useful in such kind of scenarios. That means, if we get a cohort where marriage is not universal and there are considerable number or proportion of men or women who are not getting married at all, then the average age at marriage may not be giving us meaningful results. In such situations, we can think of median age at marriage or model age at marriage. Now let us discuss about the cingulate mean age at marriage. It is also known as SMAM. It is called as SMAM in short. The age at marriage data may not be always available, and even if it is available, it may be incomplete and it may be poor in terms of quality. Hasnal in 1953 gave a method to calculate the average age at marriage in a population if data on persons remaining unmarried at each age are available. That means what we need is the data on persons that are remaining unmarried at each age, and using that data we can derive the cingulate mean age at marriage SMAM using the method given by Hasnal. Subsequently, several other indices for measuring the mean age at marriage indirectly were also derived by the researchers and demographers. However, the Hasnal's method of computing SMAM is one of the widely used methods when we refer the literature on marriages. This methodology, however, generally ignores the effect of migration and mortality. The SMAM is based on the fact that average age at marriage is actually the same as the average number of years lived in the single state by the women who ever marry, and it is also based on the assumption that the experiences of a cohort of women are the same as those observed in the synthetic cohort. Suppose Sx is the proportion single at age X by ignoring migration and mortality. The number of marriages indicated by small n and x in the brackets during the interval dx can be obtained as minus as d Sx. The formula is given here, formula number 1. You can have a closer look at this formula and understand the concepts involved in getting this computation. Then let us move to the next slide. If small d and big d are the lower and upper limits of the interval in which first marriage is occurred, then the mean age at marriage can be computed using this formula given with number 2. Have a close look at the formula which has to be used to derive the mean age at marriage. Hope you have understood the formula. Then let us continue the discussion on the computations. What we have to do is we need to substitute 1 in 2 and integrate by parts and rearranging has to be done. So if you do that, you have formula number 3 and you also have formula number 4. Instead of me repeating the formula that's given there, you better have a look at the formula and absorb it. Then one can appreciate the way the computation has to be done. It's not so complicated, it's a simple procedure given by Hasnall to arrive at singulate mean age at marriage. Let us move to the next slide. Here we are talking about a discrete approximation. The formula 5, the formula 6, you can have a closer look at this formula, and then the formula 6 is the formula for singulate mean age at marriage. Then let us look at this table. Have a close look at this table 1 that gives the computation of SMAM for one of the Indian states, Kerala, for the year 21. The first column gives the age group, 5-year age groups 15 to 19 to 50-54. The second column gives the female population. The third column gives the population single of the females, and then the last column gives the percentage of single by each age group. Look at the last column. In the age group of 15 to 19, 87% of the females were single, and this proportion of single females reduced from 87% to 42% by 2024. By 25-29, it reduced to 13%, and it continued to decline to about 6% by 32-34, and to about 4% by 35-39, and 3.5% by 42-44 and 3.16% by 45-49. By the age 50-54, 3.4% of the females in Kerala in 2001 were single. Then what are the steps to derive the SMAM? The first step, calculate the years of singleness lived by 100 persons up to age 15. The second step involves computing single years lived between 15 and 50 years of age. So we have the data in the previous table. So using that table you can arrive at this. Step 3, total years of single life lived by 100 women. You can compute this. Step 4, calculate the percentage still single at the exact age of 50 years. So this also can be computed by average of single in the age group of 45 to 49 and 50 to 54. So the computation is given here. It is easy to understand and easy to absorb. Then step 5, the single years lived by those not marrying by exact age 50. Have a look at number 5, step number 5, and understand that. Then the total years of singleness lived by those who got married before age 50. The computation is given here. Have a closer look at that. Then finally, you have the computation of SMAM. You have the numerator, you have the denominator, and the value obtained is 21.96. That means in 2001, cingulate mean age at marriage for females in Kerala was 21.96 years. That is almost 22 years. Now let us look at the Cole's indices. In the late 1960s, Cole developed 4 indices of fertility. 3 of these indices attempt to measure the overall marital and non-marital illegitimate fertility in a population, and the 4th one measures the prevalence of marriage. These indices are symbolically represented in the following slide. Have a look at this. IF indicates the index of overall fertility. The second one, IG, is the index of marital fertility. The third one, IH, is index of non-marital fertility. Finally, IM is the index of proportion married. All these 4 indices were developed with an idea to study the fertility transition in Europe by Cole. Before we move to the next slide, please have a look at the 4 indices that were proposed by Cole. The idea was to study the fertility patterns. All these 4 indices are theoretically based on the technique of indirect standardization. For computing these indices, Cole selected the fertility schedule of Hutterites, known to have the maximum age-specific fertility rates as the standard, because you need a standard population. So in this case, Cole selected a particular population having maximum age-specific fertility rates as the standard population, and then the indices were computed for any given population. These indices express the level of fertility as a proportion of the fertility the population would have had if it had experienced the highest fertility pattern on record. In this case, coal took the standard population also. So, if the country experienced the fertility patterns of the standard population that was considered, then the country is expected to have the fertility level that was obtained. The Coles indices show how close the fertility is measured, and it comes to the theoretical maximum. You have the theoretical maximum and then you have the computation. How close the fertility estimate is to the theoretical maximum. The index of overall fertility can be derived by expressing the observed number of births as a proportion of the number of expected births. If the population experiences the ASMFR, age specific marital fertility rates of the standard population. Let us move to the next slide. It has the formula for IF. IF is the overall fertility, the index of overall fertility. The index of overall fertility, the computation is explained here. The expected births worked out by applying the standard population's marital fertility schedule to women in Kerala in the year 2001. By doing the calculations, you get a value of 0.1562. This is the index of overall fertility of Kerala state. Let us move to the next slide. The same procedure is repeated to get the index of marital fertility IG, but only difference here is that in this case we use the married women and legitimate births. The formula is given and the computation is also given. You get the index of marital fertility IG. The value is 0.2239. Have a look at the computation procedure and how the index of marital fertility is derived. Similarly, one can also compute IH. It is derived as the sum of illegitimate births. What do we mean by illegitimate births? By illegitimate births, we are talking about the births to unmarried women, and we need to take the distribution of unmarried women. Let us now look at the table 2. The table 2 gives the Coles index of overall fertility indicated by IF for the state Kerala for the period 2001. So, there are several columns in the table. The first column gives the age, the second column gives the female population, third column gives age specific fertility rate per 1000 women, the third column gives the fertility of the standard population given by Cole, the next column gives the number of births, the last column gives expected number of births. Let us spend some time and have a look at the data that was provided in this table. And finally, the last row gives the computation and the value of IF, the overall index of fertility for Kerala. Similarly, Let us move to the next table that gives the computation of Coles index of marital fertility indicated by Ig for the state of Kerala. Similar to the previous table, the first column gives the age starting from 15 to 19 up to the age 45 to 49 years. The next column gives married female population. The difference between the table 2 and this table is that in table 2, in column 2, we had female population, whereas in this table, in column 2, we had married female population. The next column gives the age-specific marital fertility rate. In the previous table, table 2, where we computed overall fertility index, we considered age-specific fertility rate, whereas in case of Ig, the overall index of marital fertility, we are taking age-specific marital fertility rate per 1000 women. The age-specific fertility rate or age-specific marital fertility rate are given for each of the age groups starting from 15 to 19 to 45 to 49. Then the next column gives the fertility from the standard population considered by Cole. The last column gives the expected number of births. The column just before that gives the number of births. So the last two columns indicate the number of births and expected number of births. On the basis of this, the computation of the marital fertility index Ig is given in the last row. Have a look at the various data that is presented and then the way the computation was done to derive the index of marital fertility for the state of Kerala. The next slide gives the formula, and of course there are no illegitimate births reported in the Kerala 2001 census. Because of that, this value would be 0. However, IM provides a measure of proportion married in each age, and there is the concept of weights applied by using the standard fertility rate, and the formula is given for IM, and the computation is also done. Have a look at the formula for IM, and IM for Kerala is obtained as 0.6977, and the explanation is given about B, number of births in the population, BL, number of legitimate births, BI, number of illegitimate births, WI, number of women in the ith age group, MI, number of married women in the ith age group, UI, number of unmarried women in the ith age group, and FI, a specific marital fertility rate in the ith age group of the standard population. So we also have an equation that indicates the identity between IF, Ig and IM. So in this slide, we are talking about the identity between the various measures, namely IF, Ig, IM and IH. The formula is given. Have a look at this, and in case IH is 0, then the relationship changes as indicated here. One can also have a shortcut wherein IM can be calculated as the ratio of expected births that would occur to married women and to all women if they experienced the standard fertility rates as considered by Cole. Thus, we can have the expected births to married women. The figures are given here for expected births to married women and expected births to all the women. Using that data on expected births to married women and expected births to all women, you can derive IM. IM works out to be 0.6977 for Kerala. So, dear students, in this module, we looked at the indirect estimation of age at marriage. We discussed about the limitations in the data, be it census or vital registration. In view of the limitations of the data that is available, one has to use indirect estimation techniques to derive the age at marriage. For that, we discussed about the Hasnall's method. Using Hasnall's method, one can get SMAM, singulate mean age at marriage. We also discussed about the different fertility indices that were given by Cole. As we discussed, Cole used the standard population that was having highest levels of fertility to compute these indices, overall fertility index, overall marital fertility index, etc. We also looked into the formula that can be used to derive these indices. We looked into the actual derivation of the indices using the calculations, using the different formula. So, this module helps us in using these techniques to estimate fertility indices or the age at marriage for a state or for a country or for a group of countries. So, this module has enriched our knowledge in terms of applying indirect techniques to estimate fertility indices and average age at marriage using the indirect techniques that was given by Hasnall. Thank you so much.